Hello, hello everyone. Morning, afternoon, whatever time you have. So welcome to my talk. Today we'll talk about the code analysis, and it's called Code Analysis Plus Plus. And I have to say that these two pluses are actually not just for C++, but also for the modern trends in the language and in the ecosystem, as like we can see it right now these days. So we'll talk about what the modern tooling and language and compilers, what they all are capable about in terms of the code analysis. And we'll check the modern trends in the language and see how the tooling actually addresses the modern questions and modern problems, or how it can help you in the language right now. So if you don't know me, just a few words about myself. So my name is Anastasia Kazakova. So you can find me on Twitter um, and like in some other socials as well. So I do work for JetBrains right now as a product marketing manager for C++ and .NET tools. Before that, I actually spent 8 years in embedded development in networking area. So I was coding all types of these like routers, IPTVs, all these devices, working with embedded Linux. And I had some amazing time in the past when I was launching the first ever 4G network in Russia with our team. It was really very exciting experience. After which I decided that I will probably have to do something different. And so I started my work at JetBrains. And here I mostly like talk about the tools and about the ecosystems and try to like explain what we do to the community and try to help our teams with the community trends. So I also run a user group in St. Petersburg in Russia. So if you're anytime around, so you're very welcome to join. For now, unfortunately, we're on hold because I'm not a big fan of online user group meetups. Like the conferences are fine, but the user groups is probably for in-person communications. So I would like to wait for for the times becoming better. So, but I hope we'll be able to restart quite soon. And I also work with the C++ Russia conference. This is the biggest C++ event in Russia, and like helping the program committee to tune the program for the conference. And we'll have another conference starting in mid of November. So it's online, so you can join. We have English and Russian tracks both, so you can find some interesting content in there. And now, like to the talk itself. So I had this question in my slides, but I'm not sure. Maybe after yesterday's Bjarne's keynote, I don't need to explain why the code analysis. But let's still talk a little bit about which problems it actually addresses and what it actually helps with. And obviously, when we talk about the code analysis, the first thing to talk about is and probably the major one, is the software quality. Like, let's think about just one word, what the software quality means to you, like right now. So think about it just for yourself. Think which words actually defines the software quality to you. And I actually gave this exercise to the audience in my Twitter before I was doing the extended version of this talk for C++ on C in summer. That was the online conference, and I gave the half-day workshop there on the code analysis. And I actually asked people on Twitter the just one word that defined the software quality for them, and I got many different answers. And I would say that I really like them all because these are the different sides and the different views on how the people actually see the software quality. So there are many different things here. So you can see that there is like maintainability, or like the code should be documented, or the simplicity of the code, or the decreasing of the undefined behavior, or the battery life, whatever. So there are many things here. And I have to say that probably for every developer, the software quality means something specific to their team, to their project, to how the company work. And there are many interesting things here. And actually, there is kind of definition for software quality given by the special consortium. That's exactly the consortium on software quality, believe it or not. And they have their own definition, and they just selected these 5 words to define the software quality. It's like reliability, efficiency, security, maintainability, and size. There are other definitions, like some says that the high quality software just meets the requirements, and like that's kind of obvious, like because if the software doesn't actually execute what it has to, that's probably not a good software. Um, but like that's all good except from the fact that the definition tells you doesn't tell you how to achieve the software quality. So if you care about it, right? So there are the things you have to care about, but how to do that? And like another aspect is that there is this notion of internal and external software quality. And there is one article by Martin Fowler. You probably have heard about him, as he is great adept of refactoring and good quality software. And he has an article written in, I guess, May 29th. 19th. So it's about the is high quality software worth the cost? And he actually discusses there that there is internal and external quality. External quality is what the users see, like the UX or UI or how it works or how fast it is. And the internal quality is the architecture and how everything is built inside. And there are like some naive developers who think that the external quality matters and the internal, it could be not that important. And actually, the Martin proves in this article that that's not true. Actually, the internal quality is somehow much more important than external quality, because the internal quality guarantees that you can actually build the external quality. And there is this nice graph which shows how the kind of quality of software measured somehow um, differs in time, and how this cumulative functionality evolves in time depending on what you care more about, internal or software quality or external software quality. Because if you start caring about the internal software quality, obviously you start slower, because you have to think about the architecture and all that stuff, and you're like running lots of maybe static analysis checkers, or like working with sanitizers and all the thing from the beginning a lot. But if you like if you're quite stubborn with that, later you'll see that you can add new value to your product faster. That's what the article is about. So yeah, that's just about the internal and external quality, and that actually the high quality software, as the Martin Fowler says in this article, is cheaper to produce, because when you care about it from the very beginning, it's easier to add any new feature or extend it or to scale it to the new platforms. Okay, so software quality kind of matters, and we realize that. What else is important in terms of the static code analysis, why it actually is, so which problems it addresses? And the next important word here is developer frustration. So definitely, like when you have bad quality, it leads to developers who are frustrated about the whole application or the whole code base. There are many aspects which leads to this developer frustration. I really like the question from the C++ Foundation Light survey, and this is the results from the 2021, so this year. They actually ask C++ developers specifically. So this is our, like, our developers who are all around us. So that's us. Which of these do you find frustrating about C++ development? Because obviously, like, these reasons could be different from one language to another. And I would say that you have to mind the audience when you look at the answers, because we were analyzing the C++ Foundation Light survey results, and in JetBrains, as sponsors of Foundation, we have an access to the like raw data. We were like digging in it quite deeply to understand what the developers actually think in the ecosystem. And the audience of the C++ Foundation Light survey is very, very experienced. So the majority is like 20 plus or 10 plus years in C++. So a very experienced public, and you can see the reasons which are the points of frustration in C++ for them. So there are lots of things about the tooling and about the dependency management, like how to manage the libraries, how to deal with the project models, because there are quite many of them in the ecosystem. These are these blue lines. Also, there are these yellow lines. The first one is the build times, and the rest are different safety issues and different types of other issues, like concurrency safety, memory safety, security safety, type safety, whatever. And so, yeah, actually moving to the latest language standard, it's just the last in the list. So you can see there are a lot of issues here which bother the C++ developers. And I would say that most of these issues can be addressed in this or that way with the code analysis, static or dynamic. There can be different things here. But all of these things are kind of addressable. So if you take, for example, even the build times, so from one perspective, you can take the tool which reduces the build times, like Incredibuild, or like and optimizes the build process somehow, make it parallel. But you can also like check the code and remove the redundant code, non-optimal code, and that will also improve the build times. And so the code analysis tools, they can help with that. You can take the concurrency safety, for example, and definitely take some profiling or other dynamic analysis tools to analyze that. All this memory and security and type safety are now the subject for static code analysis tools to address. And yeah, modernizing the code base is also something which the code analysis can help the static code analyzers. Okay, so we have these points of developer frustrations. Sorry, some slides probably. So let's see what are there else in C++ which might frustrate the developers in terms of the language specifically. And this is very important, and this is the things which affect how we work with the code analysis. So let's look at this very simple piece of code. It's maybe not the smartest piece of code in C++, and it definitely doesn't need to be like that. But let's think about what it actually does. This is a kind of artificial example generated by our QA engineers then when they were testing some features in the IDE. And what actually this code does, it just returns 42. That's it. I mean, like if you remove all these redundant template things and just, all these unnecessary types. So you will just get the return 42. That's it. That's all what the code is doing. And this probably leads us to this quote from Twitter posted several years ago that the problem we do have in C++ is that we have these 10 ways of doing one thing. And that doesn't sometimes mean a good language. So sometimes this power which we have leads us to the way that, yeah, we can actually write this very simple code which returns 42 in that many lines, and you don't have necessarily to do that. And I have to remember here the book by Google about software engineering at Google, where I find this nice theorems law, which can be applied here as well. So it's not just about the API and architectures, but it can be applied to the language as well, I guess. So because if there is a way to write the code in this or other way in the language, someone will do that. Someone will be using this way, unless we have some strict guidelines enforced on the code by the code analysis tooling or by other tools. So yeah, we can kind of abuse this power in this way. And another aspect when we talk about the code analysis, which the code analysis can help us address, and which is very important, which is probably one of the goal for code analysis is for C++ specifically, is the undefined behavior. So the problem is that undefined behavior is actually many things. And the problem with that is this no diagnostic required philosophy from the compilers, because compilers are actually not required to diagnose undefined behavior. So they own us nothing. And that means we are there on our own. So we have to use some tools which will help us to find out and detect potential issues. Like that could be some sanitizers or some code analysis if it's capable, if the tools are capable of doing that. So we need our best to avoid the undefined behavior, or at least know that it could be there. Otherwise, we're in trouble, and we need some tools that will be helping us with that. And that there is a very good example of how undefined behavior could be dangerous. And this is the example which you can find in the article by the link. And it's called Fun with Null Pointers. It's maybe fun because this exploit were actually detected before it really worked out for someone. But that was a real exploit in Linux kernel 2.6 point something. I don't remember the exact version. So it was caused by the undefined behavior due to the null pointer dereferencing. So you can see that there is a dereferencing on the of the tune pointer here. And yeah, in the good case, so you could get into the kill in the process and log in the wrong system call. and that would be the best outcome for you of such code. But in worst case, null, the zero, can actually be a valid pointer address, and so there could be some issues coming out of this fact. And actually, the code is very interesting because uh, by default, the very bottom of the virtual space is usually disallowed for like this kind of access. Especially, it's actually done specifically for catch and null pointer bugs. I would say a very good workaround for this issue, but it didn't work here. And it happened that, yeah, there was even the check for this tune pointer later. You can see on the last two lines this if clause, but the GCC compiler was optimizing this check out because the reasoning was, since the pointer was already dereferenced, the compiler thought that it cannot be null. So it was optimizing the check. So yeah, in the end, so if this exploit could be, if this exploit was used, so the attacker would just jump to its own code, and so when the kernel call was kind of triggered, the result was in the arbitrary code executed in the kernel mode, which is definitely a like kind of serious attack. So luckily, the issue was caught early, so and was fixed. But here is the nice story of how the undefined behavior could lead to a very actually scary consequences. Okay, so we got the story, and now we got kind of these three reasons I mentioned, three aspects in which the code analysis could help us. So, like improving the software quality in general as a big goal, helping us to lower the developer frustration caused by many quite typical issues in C++, especially this null dereferencing or dangling pointers and all the stuff, and avoiding the undefined behavior, which could lead us to these kind of issues like with the Linux kernel. And we'll start not with the tools, but we'll start with the language. And the reason for that is like, yeah, I'm a tooling person. I'm like a fan of different tools, and I believe that the true tooling can help. But the language is the first class citizen here, so it could help as well. And I see a great movement in the language itself, in the language evolution in the committee right now, who are trying to address these frustration points, these issues which leads to the bad software quality region in C++. And I would like to mention a few recent things which are kind of discussed right now in the committee, and some of them are already in the standard, some are maybe coming in the next standard, some are probably the topic for discussion for the next versions, but it's very interesting to see these things at the table. And the first one is the lifetime safety. So this is a very nice proposal, and you probably have heard about it. So in a nutshell, so that's a way to the compiler or the static analysis tools can actually detect who is the owner, who is the pointer owner of the pointer, and who is just like using this pointer, and who have to delete the pointer, who have to free the resource, and who should not do that in any way. And the proposal assumes that there are compiler checks for that, so that your compiler can actually check that, and it can check it just through working through the control flow graph, or it can check it using the specific annotations which are implemented in the GSL library, for example. So if you just annotate your code with like, here's the owner, here's the shared owner, here's the pointer, and so then the compiler can take these annotations into account. But also it can do something on just code without any annotations. And there is a reference implementation in LLVM branch, which you can find in Compiler Explorer if you would like to play with it. And it gives just 5% overhead, at least in the current shape. So it's not capable of all the things defined in the proposal, but it's more than like one could dream maybe a couple of years ago about. So yeah, and it could actually work showing showing the arrow for this example where we like assigning the 42 for the second time to the p pointer. Uh, it's like, this is actually great. The only aspect is that that's just a proposal, and this proposal has to be worked through the committee, and also it has to be implemented in the compiler. So the LLVM now, the Clang, has just the reference branch. There is also some implementation in Visual Studio. We'll talk about this later, but in general, Like this is something about the future, so not right now. What we do have right now is just I will touch it from the perspective of this stud source location only, which we have since the C++20. And stud source location is just one aspect of how we can actually now avoid macros. And you probably like, again, if you were at Bjarne's keynote yesterday, you probably have seen the whole list of what is his dream of, what is his way of how to um, remove macros from C++. And I personally is a big fan of source location, because what it actually allows us to do, it allows us to write our old classical macro styled logging and tracing functions without the macros. So because usually when you log something, you use this, file or line or func macro to actually log the proper point in your code base. And now you don't have to do that, because you have source location current and there's a single entry to get all these things. And so you can just use this stud source location current instead of all this macro hell. And this is really great, because like relying on macros still leads us to many, many issues. And this is definitely not just one small thing. So this is a part of the bigger effort. So when combined with all these const expert and the rest of the things, so we'll probably can get the world without the macros in the end. Another aspect of how the language currently tries to help us address these issues are the contracts. Yeah, a tough topic here, and I even have two links to the currently discussed proposals, because the contracts kind of suffers. This topic actually suffers a lot, because we were planning to have them like in C++20. We didn't manage to get them, so there are now these discussions for these proposals for C++23. Let's hope for the best. Let's hope that we can get at least some implementation, some vision for the contracts in the language. And what it means actually for us, that we can mark our code with this pre-post and also like put these asserts in the code and use these marks, I would call them, like to tell the code analysis tools to tell the static analyzers that here we have to check these conditions and please do that. So they could be the compiler checking, but that also could be the static analyzer checking here. And there are right now many questions in these proposals and many discussions around like, can we check and proceed how to restore, or should we just abort? And these are definitely the valid questions, and that's probably why the contracts were postponed. And there are many still questions around the contracts to discuss. But in the ideal world, we have these annotations for pre, post, and the asserts, and we can use them to, to detect possible problems in the code. Um, and the last thing I would like to mention in terms of the language is the parameter passing proposal by Herb. That's, to me, it's a great paper, because it allows us to, again, to drive our code analysis tools to move forward with them and to check some semantic of the code. Like if we have an in parameter, is it really the parameter the function body can only read from? If it's an in out parameter, do we really read from it and then write to it? If it's an out parameter, so do we really read from it only after writing to it? All these things can actually be checkable if we have this, if we have this information about if this an in or in out or move or whatever parameter. So if we have this semantic written in via this nodes, then the static analysis tools can check them. But again, from whole list, which I really think is a great step towards better code quality in C++, only these two source location are in the current release standard. All others are just still under the discussion. And realistically, I think we could only get the contracts for C++23, and that's we have to be quite lucky about it. But let's raise another topic here. Let's think about many of these things I was discussing right now was about like how to have these things in the compilers, and that's how the proposals are currently structured. So like for the lifetimes, for example, so we have to get them in the compiler. But the problems with the compiler is that the people are not moving to the new compiler that quickly. That like the compiler is the core tool of the development, and it's actually hard to upgrade it. And GCC, even when it was released in the GCC 11, it was released the whole migration guide. So it was not that really challenging guide, but you still have to go through some procedure to migrate to a new version of the compiler. And for some people, migrating to a new compiler is just impossible, especially in the embedded era. So when they are locked with some vendor specific tools. So getting the things done in the compiler is good, but it's not that quick and it's not that realistic for many. So, but on the other side, getting things done in the static analysis in the code analyzer is much easier because you can adapt actually any tool by your team. You can get your code compiled with GCC, but you can get the analyzer based on Clang, for example, and that's fine. And yeah, like probably your code base exactly requires the specific version of the compiler, but it doesn't have any limitation on the version of the analyzer you're using. So you can tune it in any way which fits your project. And also, if you want to implement some custom checks, like custom checks in compiler are kind of impossible, but custom checks in the analyzer, that's fine. So for example, some analyzers are extensible. So if you take the Clang tidy, you can write your own custom check, which is only interested into like for your project, for your team, and you can use this check along with the others. And so this extensibility point is also very important. Uh, and yeah, probably the main benefit for analyzing the code with the compiler is that it's kind of standard to everyone. So if you have something in the compiler, then everyone can use that if they have this compiler. And with static analyzers, so like, yeah, you need to get the tool. So that's why now we will be talking about the tooling and we'll try to find out what actually the modern tooling is capable of. And I have to say from the very beginning, the tools in the modern C++ ecosystem can do a lot. So they're not just, like basic checks which the compilers can do. They're like far ahead. So we also do a survey for C++ community somewhere around the time the C++ Foundation does it. So in the end of winter, beginning of spring, that's the timing for our survey. And the developer ecosystem by JetBrains is, so we run it for C++. And we have this question like, what do you do for guideline enforcement and other code quality and code analysis for your code? And the most popular answer this year, the green bars, is the IDE built-in tools. So the people are mostly rely on the tools provided by their IDE, bundled into their IDE. So it's good to see that the non-answer is kind of decreasing from year to year. And it's good that the people see that there is a value in the code analysis and they actually use it. They take the tools provided by their IDs. There are actually other tools in the list, so that's not all we have. So, but I just cut those who are under 7% to get them, fit the slide. So, but it's great to see that, yeah, the Clang family tools, they are definitely coming after the ID built-in because that's not the standard, but nearly the standard tools, I would say, in the ecosystem right now. Um, and yeah, I have to make a step here for a while and say that um, code analysis could be run on different stages of development. It's not about when you're just writing the code or when you're compiling the code. There could be different stages. And I don't plan to talk about it a lot. I just want to say that these tools are there for this stage of like building on CI or running the code reviews or like accepting the pull requests to your open source code base, for example. There are tools to run the static analysis on these stages. So there is a very known Sonar source company who are doing this Sonar Cube, Sonar Cloud, Sonar Lean tools, and they have this option to run their analysis on CI, to run them during the code review and decorate the pull requests. And we also in JetBrains do the tool called Kadana, which brings the linters from our JetBrains IDE to like CI spectrum. The idea is that these tools are very important in some specific cases. Like, for example, if you have the checks which are platform specific and they are different from the development platform, so you simply can't run them like on your platform where you are developing. There is no way to do that. Then you have to use some tool which will run it, for example, on CI. Like there could be resource greedy checks. You can't run them probably on the developer machine. So, and there are many, many other aspects. And being, for example, a manager for the project, you just want to see the timeline of how the code quality evolves. And, or if you're owning the open source project and there are many contributors, you just want to run some code analysis constantly on a CI for your whole project to see how the things are going actually. Um, so, yeah, so these are the tools for these specific tasks. So we won't be talking about them a lot further. I just want to mention that they are there and they're important. Um, there are definitely compiler errors and warnings. I don't want to spend lots of time on them, but except for the like very standard compiler checks which you can get from the majority of the compiler, there are some checks which are very interesting, like the misleading indentation check. So how often do you enable it in your compiler to get the checks on your code base to catch some situations when you probably miss something or the indentation is wrong, indicating that there is an error, or when you're calculating the size incorrectly, like in this second example. So there is this check for size of pointer mem access, which can tell you like how actually suggest the proper size of calculation. The problem with these checks is that you need to know how to enable them, and you need to do that maybe in the cross-platform ecosystem, and it depends on the platform, it depends on the project model you're using, build system. If you are using the CMake or if you're using the Make, the flags are different. If you're using the Microsoft compilers, the flags are different from the GCC compilers in CMake. So like you're just like, for example, setting the add compile options, but in Make you are setting these 6x flags. So you need to know the way how to do that, and the project model affects here a lot. And actually, another um, plot from our developer ecosystem is that there's lots of project models in C++ ecosystem, and even though the CMake seems to be dominating right now and growing from year to year, still there are a lot of others. And you need to know how to enable the check in your specific configuration. Um, let's look further. Let's be back to the lifetime safety. So I talk about the proposals, but is it really practically applicable to our code right now? Can we use it? So are there any practical implementation except for this Clang experimental branch, which you can find in Compiler Explorer, where you can use it, but I don't think you will be using the experimental Clang branch for everyday production compiling. Um, and actually, you don't have to wait for lifetimes to land in the compiler, because the modern tooling can actually do that. And there are tools which can, for example, detect the issues like that when you have the string view constructed with the temporary string instance returned from the get string. And so when the temporary string is then destroyed, it leaves us with this reference and issues. So you can get this check in the modern tooling. And you can also get this check, and this is example, I guess, mentioned by Bjarne yesterday, when you have the pushback, which might cause the vector to reallocate. And so the like invalidate the underlying storage. So the iterator becomes dangling invalid. And these are these annotations from the lifetime safety proposal implemented in GSL. So, and like, yeah, they do help to indicate that there is this address of the local variable escaping from the local function. So the good question is where this is implemented, except for the Clang branch. So first of all, that's the Visual Studio. So you can find the C++ core check lifetime rules in there. And they're there since the Visual Studio 2019 preview 2, where they were kind of announced. And also we have them implemented in C-Line since version 2021.2, which was like released this summer. So yeah, so you can get them in the tools, and you don't need even to wait for your compiler to implement these checks. So to use them, for example, in C-Line, you don't need the compiler which supports the lifetime proposal. You just need your code, and you can enable these checks. If they're not enabled for you, they are actually by default. Uh, so yeah, and you can get this warning thrown on you in your code that yeah, the address may escape, the function may escape the local scope. Okay, that's the lifetime safety. So good to know that we do have it. Um, the next big topic is the data flow analysis, and that's actually much bigger than just the lifetimes or just think you might have heard about it. So data flow analysis, it actually analyzes how the data flows through the control flow graph, and it uses like these data points, and it uses the control flow graph and try to understand what happens to the data and if any conditions are like true or false. It's a very powerful technique if you use it thoughtfully, and it can detect the things like condition is always true when reached, like in this example. So it analyzes all the function like parameters and arguments and return values and the global variables and try to indicate such cases. And it can actually detect the dangling pointer, like in this case. So it can see that the local variable may point to a deallocated memory. More importantly, the data flow analysis, if it analyzes the whole translation unit and not just the body of the function, it can actually catch this dangling pointer in this kind of situation when I'm actually deleting the pointer in another function. So for this, I need just to analyze the translation unit or like, yeah, and this is called the global data flow analysis. So it doesn't work in all the cases, definitely so, but like it can help. And the global, like the data flow analysis in local and global mode, it can actually detect many things. So if you apply this technique to your code, it can detect the constant conditions, the dead code, the null reference in the escaping from local scope. So all these things could be run in local mode inside the function body or in a global mode inside of the translation unit. And yeah, so like another example of the null referencing caught by the global data flow analysis again. So we're analyzing the code inside the translation unit. And if you take the global analysis for the translation unit, not just for the function bodies, you can actually detect even more, because you can detect, for example, that some calls are unreachable because you're analyzing all the calls of the function, for example, inside the translation unit. Or you can detect the constant function parameters or the constant function results and also flag some potential issues in the code. Um, so the good question is if it's really possible in the modern tooling. And the answer is yes, it is. So we are now working on data flow analysis in C-line. So we started with it quite a long time ago. We moved it to Clang, but we're not upstreaming it to Clang, so you can't find, unfortunately, it in the like public Clang branch. But so yeah, we've implemented the local data flow analysis and then moved it to the global, which means inside the translation unit, and it works in C-line since this year. And we also implemented the lifetimes actually on top of this data flow analysis. There is also a data flow analysis I know about in PVS Studio, which runs it as a value range analysis, which actually tracks the range, the interval of the values for the numeric variables, I guess, and like yeah, can also get you some flags you some potential issues in the code. Um, the interesting question here is if this data flow analysis is possible in not just inside the translation unit, but like in the cross translation unit format, the CTU analysis. It is. And there is some descriptions how you can actually achieve that available in Clang documentation. So it's actually possible to expand this analysis to the cross translation unit analysis with some trade-offs, but if taken carefully, you can work them out. So there are two different approaches how to do that. So one is called the predumped precompiled headers, and one is generating AST on demand. It doesn't matter the details right now, but the thing is that, yeah, they're like dumping some information for the translation unit and can make the analysis and can analyze and actually analyze the definition of the function from the another translation unit. So, and if we're talking about the practice, in practice, there was a reference implementation for that done in so-called code checker, and it was presented at LVM meeting several years ago, and they have this implementation on GitHub. So it's not really that powerful. It can detect just a few simple cases, I guess. So it flags just a few simple checkers there, but it's the proof of concept that the cross-translation unit analysis is actually possible. So you can try and move your analysis written for translation unit to the CTU level. I don't know any real big tools who are doing that right now, but the thing is that, yeah, so the code tracker exists, the Reaper exists. That means that we actually can try and extend our analysis to the cross-translation unit level. Sorry. The next big topic is the C++ core guidelines. And yeah, Bjarne mentioned them as well yesterday. And I think that's a great piece of guidelines collected by several people. And definitely, there is a great goal of promoting the effective and right usage of the modern C++. The thing with the guideline, as with any other guideline, is how applicable they are. And can we encode these guidelines into the tooling? Because if there are no enforcement in terms of the tooling, then these rules won't be like used properly. So because like checking the guidelines manually is not the thing which everyone will be doing. So we need the tools which will support the guidelines, and there are some right now. And the interesting aspect is that if you take the guidelines, so to my perspective, to the perspective of our C++ team and JetBrains, not all of these guidelines are like easily toolable, and not all of these guidelines are even have to be toolable. And we were analyzing the code guidelines with the ReSharper C++ team half a year ago, exactly from this toolability aspect, trying to rank the rules there, like is it toolable, or is it like not toolable, or does it require some external library of like GSL, or doesn't or if it makes any sense to us as a toolable checker. So, and there are these guidelines which are easily toolable. This is just an example of how you can actually encode in the tool the rules from the C++ core guidelines. And this is very straightforward. So I just exactly, I took the rule and then I rewrote it using the kind of, a little bit of programming. Semantic here. So these F16, for example, like for pass cheaply copied types by value and others by reference to const, it could easily be checked. So because you can analyze that you're like, for example, passing by value, you can check the size, and then you can suggest like reference to const, for example, or you can suggest passing by value in another case. So this is easily encodable, and so you can catch many things here. And also this like dangling pointer, as you can see. So yeah, you can encode it in the tool. There are guidelines which are not really toolable in the fact, in the sense that um, sometimes it's not clear how to make them toolable. Like all this one like rule of one screen, I was taught it in the university, I have to admit, but I still don't know how to apply it correctly to the code, because we all have different screens right now, and the rule of one screen to my colleague might be completely different to the rule of one screen to myself. um, and also there is these rules which uses this term of similar things, and it's very hard to determine for the tool what the similar code is. And if you try, for example, to look for finding code duplicates for C++, you'll find a nice overview at Stack Overflow, and you find a few tools mentioned there, and they're actually quite good in doing some things. Like, for example, the Dupla, I guess it states that it can analyze the whole Linux kernel in less than 1 day, and it can analyze some other code bases much quicker. And the Simian, the tool which can analyze, I guess, the GDK in 5 seconds, and it can find some code duplicates, ignoring even some variable names. This is really powerful, but yeah, like, do you remember this example with 42? That's why finding code duplicates in the C++ code is much harder right now than maybe, I don't know, 10 years ago or 20 years ago, because the good tool finding the duplicates have to realize that this is the code returned in 42. So it has to understand this and yeah, actually make this kind of simplification. So yeah, some guidelines are hardly toolable because you need to apply some actually possible but hard to implement techniques like finding the code duplicates when it's not that straightforward. And there are also another aspects for the code guidelines when their interfaces are involved because like changing the things like const expert or inline or no except affects the interfaces. And I'm not sure that making them like as a quick fixes, for example, in a tool is conceptually right. Maybe as a context action, which you can suggest and the user can just ignore. But making this as a forcing as a quick fix, maybe too much. But yeah, this is kind of questionable topic. So, but the tool can definitely at least raise some warnings when something wrong is happening, like context per function uses something unavailable, for example. But forcing exactly the rule as it is might be a questionable thing to do. Anyway, there are plenty of tools supporting the core guidelines. Not any of it are supporting all of them in full. So there is the GSL library, which helps. There is a Visual Studio with C++ core checkers. There are quite many of them. There is Clang Tidy group called CPP Core Guidelines. I guess it's something about 30 or 41 checks, something like that. Sonar Source has the checks for C++ Core Guidelines. It's something about 80, I guess, in Sonar Linter. And like, yeah, C-Line and ReSharper C++, like in C-Line, it's mostly for the Clang Tidy. In ReSharper C++, we have our own implementation. So yeah, you can find the tools which do support the C++ core guidelines, but none of them are actually supporting the core guidelines in full. Uh, since we started talking about the Clang tidy, let's talk about it a little bit. So it deserves definitely a special mention as it's one of the most popular analyzer right now in the ecosystem. So and there are like these groups of checks, and there are companies who are contributing to this fantastic open source community tool, and you can find lots of useful checks there, not just the core guidelines, but also the modernized, the Google checks, which can be useful to the wider audience, their performance checks. And so you can disable some checks, you can enable some checks, you can disable all and then enable only the ones you need. You can enable everything and just disable the one which annoys you. So yeah, there's lots of things, lots of ways how you can use the Clang tidy right now. And you can also, as I said before, you can implement your own custom check, which is great because it could be very specific. You don't want maybe to upstream it to the public, but you can implement it and use it in the Clang tidy. The only aspect maybe is that running Clang tidy from scratch on every file is quite there is a performance bottleneck, so it could be quite long. So the easiest way is to run it on a Clang AST, and here the IDEs can have a benefit over the like running the Clang tidy from command line, because if they already using Clang, then they can just use the Clang AST already built there, for example, via the Clang daemon like we do in C-Line, and run the Clang tidy for it. Um, there are domain specific analysis tools, and they're definitely there because in the specific domains there is this specific knowledge, and the dedicated code analyzers they are using this knowledge to address the specific issues. They know the semantic of the code, like for example for Qt, like they work with these signals and slots, and in Unreal Engine, Unreal Header tool, like it works with this reflection mechanism they're building in Unreal Engine. And there's definitely this MISRA and AUTOSAR specification, which are used widely in embedded and automotive. And I have to say a few words about the MISRA here, just quickly, because I see a nice trend right now for MISRA that people are actually requesting MISRA in their tools, in their IDEs, not just when they're passing the certification process. And it's great because like they can. have the checks early, they can address the issues early. That means they will kind of lower the cost of the fix, and they can run some kind of flexible set of checks. They can have detailed messages, and they maybe even can have quick fixes. And this is great, and that's why this trend for having MISRA in the tools and not just use it as a certification is that popular. And interestingly, all these like core guidelines, MISRA and others, they are not about the different set of problems. They have lots of intersecting checks. Like, for example, the core guideline has these rules about the variadic arguments, and the MISRA also has it in this or that way, and the third standardization also has it. So all these rules are about the same, are about the variadic arguments and how to correctly pass them. So yeah, that there have lots of intersection. And talking about the MISRA again, so like yeah, there is lots of implementations these days for MISRA. So they're like in different code analysis checkers. The again the Sonar source, Sonar Lint has rules for MISRA. We do implement MISRA in C-Line. There is implementation in PVS Studio, in Cvelop, and maybe in some others. I just don't know all of them. So you can check MISRA right now, but I don't know if there is the full support for all MISRA rules in any of these. So anyway, there is like some portion of the check supported. And the last story for the day for my talk is about this style and how this is all related to the static analysis. So actually, style is about readability and more accurate code, but it's also about safety and error-free code. And that's why it's important to talk about the style when we talk about the code analysis. And I definitely have to mention the Clang format here, which is nearly a formatting standard in C++. And you can often find the open source projects on GitHub with the Clang format config committed to this project. So when you can just, um, take the project from GitHub, and then you already have the config, so you can use these formatting rules applied by the by other contributors. The issue is that sometimes it's like yeah, not compatible between the versions, especially when they're changing some things in how they treat the parameters, like they had the parameters with true false values, but then changing them to the enumeration values. And so yeah, this breaking compatibility stories happen there. They have this kind of the fuzzy parser, which is not a true C++ parser, so it sometimes behaves differently to the real C++ parser. But still it's the standard, and it's integrated in many tools, Visual Studio, like C-Line, ReSharp, C++, whatever IDE you take. Quite likely there will be support for a Clang format, at least via some plugin. um, Naming story here is also important. There are lots of styles on how to name the variables, the functions, the classes, and there are lots of predefined styles like Google style or LVM style or Unreal Engine conversion. And the interesting story here is that um, to enforce the proper naming, you need not only just to have the checker, you also need to have the tool which is capable of renaming the thing, doing the actual refactoring, because like renaming manually, changing the naming manually would be like a nightmare. So you need a tool which will just rename the things for you. That's why when implementing naming in our tools, we always couple it with the proper refactoring. So the quick fix is actually to do a rename refactoring. uh, yeah, and the last is the syntax style. So this is how we can write the code. This is about this 42 story. You can write the things differently. You can use auto in like everywhere, or when it's evident. You can use the east const or the west const. You can do the type defs or type aliases, and this story about the trailing return times, because this is the only way for lambdas and for consistency. Some people think that it has to be everywhere, or and there is the opposite view on the problem. And also this is the story about like when to use override, final, and virtual. All these things are the syntax style, and that's how we write the code. And so if you want to have the guideline, so you probably want to enforce it on the whole team, and that's what we do in ReSharper C++ with this whole set of different settings. So sorry for that many settings, I have to say, but you can actually configure the style you prefer, and the plugin, the ReSharper C++ is a plugin for Visual Studio, will enforce this syntax style on your code. And yeah, it's available there since ReSharper 2021.1, so we implemented it this year. Uh, I guess that's the whole list of aspects and tools I wanted to talk about. So I will keep the slide with the references so you can find some articles I was referencing here. I will check the questions and the chat. Uh, Yeah, let's see what we have here in terms of the questions. So the question about the Clang tidy. So can Clang tidy be compiled separately from LVM? I tried writing some custom checks some time ago, and having to recompile entire LVM just to get my check working was a major ergonomic hurdle. Uh, like LVM is a huge wrapper, but you can just build some specific things from it. So you don't have to build everything. So there is these options which you pass to CMake, and you can build just the Clang tools, or you can build much more things like with tasks or without tasks. So there are options. So that's just how you configure that. I don't remember the whole things you need um, to enable to work with the Clang tidy. I think that's quite many of them, but it's definitely you can avoid building the whole LVM Reaper. So not all, but yeah, it's not that small maybe, but it definitely worth the effort. I mean, like when you have your custom check, especially if it takes into account some very specific semantic you have on the code. If you are using, for example, some kind of a DSL, then you can write a check which will take into account this DSL. And you can implement this check, and then you can build this Clang tidy binary, and you'll be using it, and your colleagues will be using it. And in many modern tools, like I guess I'm not sure. I guess the Visual Studio also does that. We do that in C-Line and in ReSharper C++ when you can pass the custom binary. So, and it could be your custom binary, the Clang tidy with your custom check. And the ID will be, for example, showing your custom check and the way it shows the others. So I think that that's an awesome job. And so that definitely was an effort. Um, the next question is about MISRA. So, do we have some MISRA specification for modern C++? Which tools do you recommend for MISRA C++ checks? So, yeah, so like there are different versions of MISRA, and the AUTOSAR is probably the more modern version of MISRA, I would say. And there is definitely an effort on moving MISRA forward. I guess there is a talk by Michael Wong on MISRA for evolution here at the conference. I guess I don't remember if it's today or tomorrow. Um, but you can find it by the word MISRA in the shadow of the CppCon. So there are lots of checks there, and they're very useful. And there are these latest standards for MISRA and for AUTOSAR, and there are people who do care about it and who evolve it further. Um, so um, yeah, like regarding the tools, and maybe addressing the next question at the same time regarding the tools support for AUTOSAR in C-Line and ReSharper. So in C-Line, we have MISRA implementation, MISRA for C and MISRA for C++. AUTOSAR is planned for the next year. So we're just dealing with it step by step. So we have quite many rules implemented. Probably something about the half of each standard, and we're moving forward with every release, and I hope that will address the AUTOSAR next year. Um, there are no MISRA checks in ReSharper, I guess. There are also MISRA checks in Sonar Source, in Sonar Lint, and so you can use it as a Sonar Lint in Sonar Cube, or you can use the Sonar Lint plugin for C-Line they implemented several months ago. So you can get these checks there. So, and actually there is a different set of checks. So I would say that our set of checks implemented in C-Line and the set of checks implemented in Sonar Lint, they're kind of intersecting, but they have a good coverage when combined together. And I know that there are also MISRA checks in PVS Studio, I guess. And I'm not sure if there is any plugin for Visual Studio. I think it should be there, but I never met it actually. Maybe just Dishonor lint itself. I guess it could be used as the plugin for Visual Studio. So that's in terms of the support for the MISRA checks in the tools. I hope that answers both of the questions. Um, if you have more questions, please let me know so that I can answer. I guess I answered this about the AUTOSAR and I don't see any others. Um, yeah, and nice comment in the chat about the Clang format, always recommended. I do recommend using the Clang format as well, actually, because it's definitely nearly, you know, nearly a standard. The problem is that you need to agree with your team which version of the Clang format you'll be using because of these breaking compatibility issues. I've seen many times when the team is using the Clang format and the team members are using different versions of the Clang format and they have some incompatibilities in between and the team has an issue because they are reformatting some piece of code constantly between the commits, and that's the nightmare. So you have to stuck to some specific version of the Clang format in this case. So it's not happening that often, but there is still, yeah, this pain is still there. So and yeah, indeed, many people are stuck with some older versions because of that, because they simply can't move forward. They will need to, reformat the whole code base, and they will need to, update the rules for the whole team. Uh, okay, so I think I answered the question about the AUTOSAR. Anything else we have here? Um, Yeah, so if you have any other questions, I will be going to the Gather Town right now. So I will be glad to chat to you there if you have any topics to discuss about the code analysis or the tools in general. I will be happy to do that. So thank you very much for coming to the talk, and thank you for your questions and your nice comments in the chats. Thank you, and have a great conference day. Thank you.